Section 6.1, Probability distributions are models of random experiments. Okay, let's define what is a probability distribution. It's a tool that helps us by telling us two things. It tells us all the possible outcomes of a random experiment and the probability of each outcome. Now there are two different types of outcomes, so we're going to have two different types of probability distributions. The first one is a discrete outcome. That's numerical values that you can list or count. So for example, the number of students in our class. Here's a visual example over here. That would be like there's 1 student, 2 students, 3 students, 4 students, 5 students, and there's no in-between value. There is no such thing as 1.5 students or 2 3/4 students. The second is a continuous outcome that cannot be listed or counted because they occur over a range. An example would be the length of time of your next phone call. So that would look more like this because time is continuous. I can break time apart into any tiny increment. I could count it in hours or minutes or seconds or milliseconds or nanoseconds. And there are all of those little between values that really do work. And that's the difference. Okay, so we want to be able to tell the difference when we read a question about whether the outcome we are having is discrete or continuous. So this first example says the weight of a sub sandwich from Subway. Well, if we weigh something, we can get all of those tiny little incremental values of pounds or ounces or grams and just all these teeny tiny measurements. So this is going to be continuous. The time elapsed from when you left your house. So again, time is always continuous. We can measure that very precisely, very accurately, all those tiny little fractions and decimals. The number of people in the next passing car, people are always discrete. 1, 2, 3, 4, there are no fractions there. And the number of eggs laid by a bird, well, again, we would look into a nest and say there are 1, 2, 3, 4, 5, etc. eggs. That would be discrete. So you want to be able to recognize whether you're talking continuous or discrete because that will lead you to what type of a probability distribution are you going to create. Here's an example of a discrete probability distribution. So I'll write that here. So as you notice, this was a book on Amazon that could be rated as 1, 2, 3, 4, or 5 stars, and there was no in-between values there. You could not give a rating of 1.5 stars. So on the graph, notice again that there are no in the middle values here, that everything is either 1 or 2 or 3, no in the middle. So it shows us all of the outcomes. These are all the possible outcomes. And then each line represents the probability of each one. So that's what a discrete probability distribution looks like. For continuous, what we get is a probability density curve. So we get this curved figure because every value between these two certain values, every little increment could work. And the total area under that curve is 1 because it represents the probability that the outcome will be somewhere. Finding this area is not easy. So like what you would have to do here in this example is says a coffee shop knows that everyone gets served between 0 and 5 minutes. So that's everyone between 0 and 5. And they are wanting specifically to look at the probability that you would wait between 0 and 2 minutes. So they're looking at this shaded area right there. That's how you note the probability is you shade a certain area under the curve. Well, finding shaded area under curves is not easy. Mostly you need calculus to do that. We used to do this with tables back in, the olden Stone Ages with statistics. But for us, thank goodness we get to use technology. We get to use StatCrunch for this. It will calculate those areas for us.